We're starting up the Google Hangout right now, so about 100 of our closest friends around the world, except in Antarctica, are joining today. We think, in my experience, that when people sign up and they don't pay for it, they often drift away, especially if you're 12 hours out of sync with State College, Pennsylvania. Maybe you have something to do. So we'll wait just a little bit so they can get hooked up. Okay, well, why don't we get going? It's time shorter or longer than we think. I don't know which it is. If you're in the room today, you shouldn't be using Google Hangout. Google Hangout's going out. The rest of the world has to suffer with that. So we'll see how that connectivity works around the world. But today in this room, let me give you a couple of room tips here. You can have water in this room, but no food or any other drinks. Okay? And I was told that by the management. They'll come in and check on that. There's PSU wireless available in here, so if you need to get connected, you can, but you don't need to use that except for a couple of downloads. I have a stick here. If some of you have trouble getting logged in and downloading some of the things, I have a USB drive here that you can use to download the files, or at least put the files in. If you haven't been in this building before, the restrooms are that way. Men and women, separate restrooms on that end of the hall. And the next break we're going to have is at noon. So as an adult, you'll have to make your own decision whether you need to leap out of the room. And I trust that you will. So I know most of you, and I know that you will do that. So, but our next official break will be that time. The wizard over here is Chad. Wave to people. Chad he's our primary web weapon today. This, as you may know, is being broadcast simultaneously on Google Hangout on air. And so pulling that together is a little bit more difficult than it may seem at times. So Chad has it all set up, and we have about 100 or so people who are at various places, all except in Antarctica, but in a lot of different places, India, Africa, South America, every continent. I don't know how many of them are on now or how many will be able to get the signal. I really don't know. My experience with this is if you don't pay, you don't necessarily show up if you're 12 hours different. I'm sure there are people in Korea waiting at this moment to get engaged with this. I think so. Yeah, I do too. So the other thing is that there are lots and lots of resources about R, the program we'll be talking about today, that are online. I mean, it's heavily documented, heavily sampled, lots of tutorials, many videos, lots of things. Chad has pulled together a website. The link is at the top of the page in your handout, and this is at chadche.com/wp/project/r. Chad has a lot of stuff there, a lot of books, and there are a lot of free things available, lots of videos. So we're going to be kind of covering the very surface, skimming over the surface of R today, and really taking a very introductory approach. But believe me, there is introduction, intermediate work, and very advanced work that's available for free on the net to learn more about R. So, as R is often described as an open source, in other words, lots of people work on it, extensible programming language. Extensible means that it can be added onto and people contribute things. So you are, in addition, an extensible learner. So you'll be able to go out in the web and latch on to other things that you need as you go along. There are lots and lots of resources, but Chad has some really good books, videos, starter videos, websites. What else, Chad's on there?
The links that related with the R, and there's a statistic location.
Yeah.
And R related tutorials and tutorials.
Yeah. So R is primarily a programming language, and there's Chad mentioned here for the folks who are some other place. That his website has links to a lot of those, but that's not the only place. All you have to do is do a Google search on that, or go to the R project website, and you'll find lots and lots of tutorials that are available. And also now, Chad is here. Wave to the camera, Chad, while you're here. You're not in front of this. Please come over. Chad's done a lot of work on this. He's our web weapon. Okay, we've weaponized him here. He has everything going together, and he worked really hard to get this going. Thank you. And we have a couple of other people in the room who are going to help out. Yu Kyung is sitting over here. She's the floor manager here. Yu Kyung is going to listen to this over the net and kind of make sure that we have audio going out. Now, there are people who may be not getting audio at some point in some part of the world, and I don't know what to do about that. But if we're the problem, we're going to try to fix it, and so she'll be able to tell if there's a big clamor on the web about this. Also, people who are at a distance and are connected via Google Hangout on Air are watching this, and on their screen they have a separate panel. It's called a Q&A panel, which is a brand new Google tool, and that tool is going to allow them to ask questions, because you can't have much interactivity if you have 100 or 200. President Obama had one of these Google Hangouts on Air, and President Obama had, I think, something like 200,000 people involved in the Google Hangout on Air. Obviously, he wasn't chit-chatting with each one of them. So they were bringing in other kinds of questions and answers. So Google has probably purchased this tool called Q&A, and people will be able to ask questions, and when the questions are asked, Yu Kyung will be able to see them, and she'll pull them together, and we'll answer questions in this room, and if there are additional questions, we'll do this. Also, when we answer the questions, we can tag them, and we can see this in video. The whole thing will be available on YouTube video. There'll be 2 parts to the YouTube video, because Google Hangout on Air only allows a 4-hour total single recording. So when this is done, after a couple days of editing, we'll have the Hangout on Air in 2 parts available on YouTube. And as I said in the notes, it's fascinating stuff. If over the holidays you don't have anything to do, you can sit down, get up early in the morning, and watch this, over a cup of hot coffee or tea. It's great. So that'll all be available. So there might be lapses in the audio due to net congestion out there, but we're going to try to take care of it. Otherwise, if you're at a distance and you're listening to this and you really have a lot of trouble and you don't see us panicking over here, you might want to restart your Google Hangout and try it again. Now, in this activity today, we are going to be dealing with this program called R. You may have seen the promo on R. R is as I say, it's an open source project. It's primarily a programming project, but R is adapted for data preparation, data analysis, data visualization, and reporting. Even though you may have seen some of the kind of things that you've been doing, it's all this command line stuff. Actually, people can prepare fully prepared manuscripts out of R with tables, figures, and text and integrated. So there's really a lot that's available. So it's open source, which means that you can that people can add on to it. Now, what's happening in the world right now is R is actually taking up a larger share as time goes along of the data analysis space, market space. And that may be because it's free, but as you know, free isn't always without cost. Okay? So a lot of times free may mean that you have to do a lot of work on your own. Well, one of the good things about R is that it's extensively open sourced in the crowd. If something new comes out in SPSS or SAS or Stata or any of these other packages for which you may pay a lot of money, immediately somebody has a need for that, and they will probably create it in R. So it very quickly catches up. And the other thing is, and somebody said to me, well, if you have an open source product like R, it'll have errors in it and they won't get detected and it'll be a problem. Well, I would say that our experience with crowdsourcing these kinds of things is that when errors occur, they become visible very quickly. And there's often a very vigorous group that will go around and kind of correct these things. So it's really, in many ways, self-correcting. And I just remind you that if you think that commercial packages are without error, you're probably wrong. I have actually seen, well, I'll give you an example. SPSS reliability program at one time was making the wrong calculations of internal consistency Chromebox Alpha. At one time, Proclogist, which is a logistic regression program in SAS, was preparing what a lot of people thought were upside down regression coefficients because of the kind of strange way that the dependent variable was classified. There are people always complaining about various packages about how they do regression, how they invert matrices and do kind of geeky mathematical things that are a little different. And a lot of these differences may seem small to us, but to the world out there that plays in mathematics, it's, you know, war activity. So every one of these programs is not necessarily perfect, and as you know, this is kind of parallels what went on with Wikipedia. Everybody said Wikipedia wasn't going to work out. Well, Wikipedia has errors in it, and so does Encyclopedia Britannica, too. So, I mean, you just have to watch. So anyhow, this is open source. It's free. I like free. And I'd say free, as I say, free doesn't usually mean no cost. It's free. And there are some costs. You have some maintenance things. But on the other hand, free, there's no cost to you to download the program, get its updates, use the packages that go with it. There are probably a few add-on products where people are asking you to pay for them. But for the most part, it's free of charge to you. Your only cost might be a hidden one. If you have to make a change from something you're doing to R, you're going to have some kind of transaction friction that might go on in there. It has some cost in that, for instance, SPSS is a point-and-click environment. Okay? And a lot of people like that. But a lot of times I find out when people point and click, you say, what did you point? They say, I'm not sure. What did you click? I don't know. What did it produce? Let me check. Okay, so a point-and-click environment is really nice, and it looks really friendly. When I started out doing data analysis, you couldn't do a regression analysis easily. Now anybody, 7-year-olds can go in and put data in and press a button and get the stuff out. So the ramp up on getting it done is not that hard. And in R, I think there's a bit more of a technical challenge to you to get in. And also, you really have to think about a lot of what you're doing in R. The other thing is it is documentable. You're going to write some code that you'll see. You can keep that. You can find out what you did. You can comment on it. You can, the environment encourages you to have that sort of an approach. So I think that's the other part of it. So it's open, free, extensible. Again, you're going to find out that R has a lot of things. We were preparing a proposal, and Chad was working on this. Rose was leading this. It was a proposal to the Center for Rural Pennsylvania, and it had to do with fire stations. We had to put a map in of the fire stations in Pennsylvania. So how do you do that? Well, we were able to acquire from a website the addresses of all of the fire stations. We geocoded them. In other words, we got their latitude and longitude from their addresses. And then we used that geocoded data in R to create a map, or several maps, that was produced very quickly. R does all sorts of things, mapping, social network analysis. I know a lot of people are interested in lots of things, lots of graphics, good graphics. And so it's a pretty good environment to work from. So here's the way we're going to work things today. First of all, I mean what I said. We're not going to do everything. We're not going to cram all about R into one session. Some of you who have some experience with R might say to this, well, this is kind of R light today, and it's exactly where we're going to go. We did the survey of the people who signed up for this experience. About half of people had no experience with R whatsoever. Some had some experience. There are a few people who had extensive experience. We're really gearing this toward people who have no experience. Okay? So the motto I have is, take it slow, make it go. Okay? So we're going to do that today. So if things slow down for you today, help the person next to you for whom there may be more difficulty, okay? So what we're going to be doing today, we have this broken up into a variety of little modules of instruction. Hi, again. And in these modules, what we're going to be doing is giving you a little demonstration. Then we're going to ask you to practice some of these things. Now, we're not going to give you the answers to these things. You may have to look around a little bit. You may have a little bit of pain in this. You may need to help each other out. So have a short amount of time with that. And then we're going to come back and take some questions and answers that you have. Now, during the guide, I'm going to call it guided practice because during that time, Chad and I, Rose, will be able to walk around. You should help each other at that time too. Okay? R is kind of a, I would say, somewhat non-forgiving language. In other words, if you're used to working in software where it doesn't matter whether you have upper or lower case or whether you have a space or whether you used a period or rather than a semicolon, R is pretty non-forgiving. You have to follow that thing. So a lot of times if you've been involved with programming before, one little thing that you did one step before is the thing that looks like an error later, and you usually have to get into diagnosing and fixing those things. So, okay. So that's where we're going to go. We'll go to about noon. We're going to take about a 20-minute break at that time. We'll reconnect, and then the morning is going to be, the first part of this will be mostly about, I'm going to call it mousing around and learning a little bit about R and what you need to do next. Then the afternoon, we're going to deal with a little bit of analysis, and not very much analysis either. I checked, we did had a question in your registration that asked about the experience with data analysis. Probably people have a little more experience with data analysis. We have a fair number of people who don't have any experience at all, so we're not going to take it too high on this. When you get done with this, you have R installed. You'll have a chance to learn about some of the functions and how R works. You'll see a few things that it can do. You'll know a little bit about the resources that you can do to follow this. Right? So, just curious in this room, how many people have used R in here before? Okay. We have a few people. All right. Help others. Okay. All right. You should have R installed on your machine. And if you want to follow along with me on your own machine, you can do this. I have R on this particular machine, this lab machine here. And I'm going to go to the R Studio. You actually downloaded R and R Studio. R is the program that's completely command line driven. In other words, you have to type everything into it. R Studio, I know people who do R alone say R Studio probably is wimping out. You know, you actually have 4 panes and a little bit of guidance in it. But believe me, it still probably will be a challenge. So you should be launching R Studio. R Studio will then launch R into a more usable interface. And let me launch R Studio right now. So we'll try to do that. Okay. This is my view of R Studio. Now, some of you may have only 3 panes. There are actually 4 panes here. One, it says source, this one says environment, this is files, and this is the console. If you have only 3 panes in here, you should go up under the menu and open something called an R script. R script will then appear in the 4th pane. So if you have 3 panes, you want to have 4 panes. And you get that by putting in R script, okay? And I was using my phone as my mouse, so I'll put that over here. Okay, so there are a couple of things in here. There are 4 panes, and basically we're going to be entering commands into the upper left pane. This is where we'll enter most of our commands. This is a script pane that has, it'll take the commands. The commands will be executed and they will show up, the results for the most part will show up in the console, which is the lower left pane. Okay? And then we're going to have, there's another pane up here, we'll keep track of the data and other kinds of things we have, that would be upper right pane. And then we have access to various files, plots, and other sorts of things, and help in the lower right pane. So we have 4 panes in here. Now I'm going to go through a little bit on the configuration of R, just so you know how this is set up. And I'm going to open up the preferences under R. So under the menu, I'll open up the preferences, and you come up with something like this. You may or may not need to reconfigure. I don't recommend that you do too much in this, but I will want to show you around in here. You're going to be able to read all of the files we're going to read today. We're going to have on our desktop, but you can place them anywhere you want, and you can store various directories in place. You can change that on here. Most of this I wouldn't change in any way. There's some stuff about coding in here. This changes the environment that will be available in the upper left screen in the script area. And for the most part, I'm letting that stay as it is. I don't have any other needs with that. The appearance. Now, some people like to change, they don't have the same eyes and they've got a great big monitor, so they may want to change things. So they might want to do something like changing the font size. So you could do that. The other thing is, so you have this, you can change the font. Also, there are a variety of skins on this that if those get you interested, well, then you can change those. For instance, like here's a solarized skin. Okay, different kinds of skins on these things. But mainly, I'm going to bring up the point size so that you can see things a little better on the examples here. So I'm going to bring this up to, right now, about 14 points. So let's see how that works. And the other thing is that R lets you make a lot of choices. So we have 4 panes up here, P-A-N-E-S, like panels, like windows. So we have 4 windows on the screen. In the upper left, again, is where the commands go in, the script screen, a window, the pane. The lower left is a console where the results, for the most part, will appear. The upper right is an area that contains mainly files and environment and other kinds of things, and then, rather, the environment that we're in, and also the plots and files and things will be on the lower right. And you can move these around. I'm not going to move them around. I've gotten used to this. At 66, I like 4 panes, and I know where they are. You move them, and I might not be able to even find my socks in the morning. So I'll just stay the way this is. But you can move that around, and you can change the point size. You do a lot of things in this. And there are a couple of other things here. Now, because, as I said, R is extensible, you can take it, you can do other things with it. There are what are called packages that are loaded in here. So this tells you where you'd find the packages. I'm not changing any of that. Some of this has to do with output. LaTeX is an editor that a lot of people use. We will not be going into that. I'm not going to deal with that here, but you can change it. The other thing is that if you need a spelling dictionary in here, and many of us do, then this one happens to be loaded here, and it works for it. So those are the panels, and that's basically how that works. So I'm going to leave this here. Now, so the other thing is that you need to watch what you're typing in these cases here. So I just want to caution you right now that, as I said, R is kind of picky about syntax and case, so that if you're supposed to have a space, there needs to be a space. If there's supposed to be a character in there that's uppercase, it needs to be uppercase. If it's all lowercase, it has to be lowercase. It's very picky about that, and it will. There's a difference between a lowercase x and an uppercase x. So if you're supposed to use a lowercase x and R is expecting the uppercase x, it's going to say, I don't even know what that is. Okay, so you have to be able to do that, and so the other thing I want to show you about this space is that we're going to be working on a variety of things today, and when you do an analysis session, you're frequently dealing with putting it all together in something that R calls a project. So when you're done working for the day, you've put in your 18 hours and you're working on your thesis or your paper, and you don't want to work at 24, then you can go up and save this under the File menu. And when you save something like this, I'm just going to call it test here. When we save test, this saves this entire environment. And if you notice in the upper left-hand corner of the upper left pane, there is a project name now. So I saved this project. Everything that's with it, data sets and all of that, will be saved under this title, under the file name test.r. Where is that? It's stored someplace in your computer. If you're trying to find out how to find it, just do a search. You'll see it. It's often, you know, it's some deep spot in your computer. You can figure out where to put that. That's actually something you can fix and change and decide where they're going to go. But anyhow, when you're working on something like this, you'll want to save the project because it'll save the data, save the commands, all this other kind of stuff that you have. So that will be important. And you can see in the lower right-hand panel on my screen, I've saved test R, and it's actually showing up as one of the files that's at the root level of my computer, is where it ended up. And I can choose where to put that later on. But so if I were to stop working my 18 hours of analysis and I want to get up the next morning at 6 a.m. and begin again, then you can just go in and double-click on test R, and then the whole environment will open up, and you can begin where you left off. Okay? And R is pretty good about this. It'll tell you, you know, what you need to do here. Okay. So one other thing here, R is has a lot of information about itself. So if you say, there are books about R, you could say, well, where do I find the one little cheat sheet? There are little cheat sheets about R, about special commands. But if you ever are at a loss for anything, you can type in. Let's see. So you could type help start and then 2 parentheses. Okay. Now what this is going to do is going to bring us to the book. Now when I have this in here, I want to show you how you execute commands. That we've typed a command in here, which is help.start open close parenthesis. Okay. And so how do we get that to work? Well, one of the ways to get any amount of code that's in there, I'm going to pick this one piece, is you can highlight it like that. And then the quickest way to do it is to do a command return. Okay? Now, if you don't know how to do if it doesn't work for you as a command return, you can always press the button that says run. Okay, let me do that one more time. So here I've highlighted the command I want to run. I pressed command return and it executed, and here, lo and behold, here's the help file on the lower right-hand pane for R. Okay, so that's one way to get it done. I could also press the run button; it'll do the same thing. So in R, you can use, there are commands that are on the panes, but you can also use keyboard commands to get things done. And you know, control return. Control return will get you to that spot. Okay? Now you notice also I executed that, and when it was executed, it was documented down here. So the console shows me what happened. The script part shows me what I entered. The lower right-hand pane, in this case, how I have it configured, is showing me where this all ended up. Okay? Now, another feature, now this has to be spelled correctly. You have to have the period in there. You have to have the parentheses. It has to be done correctly. But another thing we can do in here is document this. So anything in a command line, every line in R is executed one line at a time. So in this line, I'm going to execute help.start. I want to see the help file. But I've also put a pound sign in, and anything after the pound sign will be treated as a comment. So let me execute that one more time. Okay, now, you notice that I executed the same thing, but in my console, where I'm documenting what I've done, it's keeping track of the fact that I can put a comment in there. So if I'm doing something that might seem obscure in some way, you can comment this extensively and keep it in the console. Okay. So one way to get to the help files is actually to put in help.start. Bang. Okay, now, as we go along, there may be times when we'll have particular commands that we want to know about. So I'm going to take one command here. This happens to be a function. And let's say I'm working with something. I want to find the absolute value of something, but I really don't know, of a number, rather. And I don't really know exactly how to do that and what the command is. I know what an absolute value is, but I don't know how to work the command. Well, I could type in help, open parens, and then the term. So let's put ABS in here. And I'll put a little comment in. Okay, so I'm going to highlight this, and then I'll execute it. And so I'm able to get to particular functions or commands in R that I might, not know something about. And the cool thing about this is it'll give you a description. Now, shift into your geek math talk. We have a math major here who will interpret mathematics for us here. So it'll give you a description, tells you how it's used, what the arguments are. The arguments are the things that go inside the parentheses here. And tells you a few about the details. It gives you some references, how you can find out more about it. And also it tells you about other things. If I can get the mouse to work, I'll be okay. And then the other neat thing about this, it'll give you an example of how it's been used. So the help files can be really good if you're working, kind of struggling with a command. Like we'll be using something today called plot. So let's try that. Now notice what I've done here. I didn't type it all in again. All I did was alter the command line up there, and that's one thing I can do. I just altered the command line, and I changed help ABS to help plot. And I'll run that. Okay, so there's the help file for how to do a plot. Okay. So R is what I would call pretty responsive, a little geeky, but pretty responsive. Okay. Now, before we move on to this next little topic here, do you have any questions about what we've done so far? This is I would call it mousing around. Okay. And just remember, keep the Excedrin bottle close by. It's not necessarily forgiving. You make a mistake. Now, again, if you haven't done any programming, you need to kind of get the feel. When you make a mistake in programming, you'll get an error that shows up, and you'll say, my gosh, I have an error. What do I do? Well, you have to have an approach to this. Typically, when you make a programming error, your error is either in the last command or maybe the one before that. You can't kind of look at the command. You got to kind of look back a little bit. And so a lot of times you've made a mistake. If the computer says you've made a mistake, bow to it and say, yes, I have, and find out what went wrong. I had more than a couple of years ago, about 15 years ago, I had a student who came in. We used to do submit jobs to the mainframe computer. He came in on the weekend. He ran the same job, the very same job, over 100 times because he was absolutely sure that the mainframe computer was wrong. I'm not sure he finished his degree, but so if it says you're wrong, you've done something wrong. It may not be obvious, but you got to find out. You have to diagnose. You have to have that kind of diagnostic feel to it. Questions about things you've seen? Yes, sir.
Can you show us what an error message looks like?
May I show you what an error message looks like? I don't make error. No, you'll see a few today. Let me try it. Okay, I'll put something in here like, let me misspell plot. And I'll get rid of that other parenthesis here. Let's see what happens when an error. Yeah, thank you for suggesting that. Okay, it's just giving me this plus sign, which then completely goofs me up. Does anybody know how to get rid of that plus sign? Do you know, Gene? What?
You have completed something.
Oh, it's waiting for me to do it. Okay, so let me complete it. God help us. Okay, all right. Yeah, it said, so, yeah, good. So what this showed me then, I made an error. I typed in, it had plot misspelled, and I forgot the tailing parenthesis. And then it gave me that little plus sign that said, try to fix something. So I tried to fix it, and then it told me it said unexpected symbol. Okay. Now, what the unexpected symbol is in this case probably is that it expected that the plot would have T in a closing parenthesis. It expected that, but it doesn't tell you exactly what the unexpected symbol is. The unexpected part of this is for you, not for the computer. Okay, so you have to dig that out. Now, this is a simple error that I made, but sometimes your errors can be more complex. Sometimes you don't get back complete, diagnostics on this, and if you don't, then you need to kind of look and say, well, I probably made a syntax error. Okay, I've misspelled something or like. Okay, so you need to get at that. A little bit different than Microsoft Word that makes all the corrections for you and all that. This is, it's a little bit more command line environment. Okay, other things. All right, let's get to work with this now. A couple things I want to show you in terms of this environment here. These things in test R are up here. I've updated the lines. I could have just added additional lines in. So let's just do that once here. Okay, and I could execute this one. Okay, or I could even execute the whole pile of them, right? Oops. Okay, so I have a whole bunch of things in here that I've executed, and, all at once. So I can do all. R actually looks and executes line by line, but you can submit more than one line for R to consider. So I've done that. Now I could just continue this. I might have a really favorite set of commands that I use every once in a while to check the frequency distribution of something. Well, I might just put a command up there, and the only thing I have to change in that frequency distribution will be the variable name. So I might keep that up there. So I don't have to type it in again, and I can just highlight it and go. So that's one way to do it. Another thing that I wanted to show you is that in this bottom pane, I actually cleared the console. If I do a Control-L, it gets rid of everything that's in the console. And that may or may not trouble you, but if you can always execute the command again and get the same stuff that's in there, okay? Okay. Anything else? So there you are. Make your errors, diagnose your problems, and move on. Pretty soon you have glasses like mine and, be hunched over, drinking lots of coffee. I'm going to do a few calculations in there. R is a great calculator. People even use it instead of Excel and other kinds of things. But let's just put a couple things in here. There's 1 plus 1. I think we know the answer to that if we run it. Down at the bottom, we get in the console, we get a repeat of the command, and then we get the answer. Okay? So we can do ordinary arithmetic in this. Let's just try this. How about 100 divided by 20? Whoops. The thing I always forget. I got it in the right line. So we have 100 divided by 20. What's the answer to that? Well, we can run that. Okay? So that's duplicated. How about 50 minus 20? Okay? I can calculate that. Okay, so you can see it's producing the little what's being calculated, and then the answer is up there. Now, again, I could highlight all of these and do them at once, and it just does all of those commands again. So I highlighted the commands I wanted to be executed. I pressed Control-L, and I got them executed. So I've done, let's see, addition, subtraction. How about multiplication here? So 2 times 3 equals 6. Big deal, right? Okay, so you can add, subtract, multiply, and divide in this pane. Let's take a couple of other things. We're going to use a couple of functions now. So how about if we take, I'm going to take the square root. And again, these are functions. If you use Excel, these are essentially the same words you'd use in Excel. But if we took the square root of 36, okay, I can run that. There's the answer. Okay. How about if I take the square root of 30 plus 6? See how that works. Okay. So I was able to do some arithmetic inside the function too. And you can put functions in functions and do arithmetic in functions and things like that. Okay? And again, I'm just executing these line by line, but I could execute the whole pile. Let me show you a couple of other functions, and then I want you to try these on your own. So here's an exponential. So let's run that once. Okay, there's our exponential. That's taking e to that power. And then a couple of other functions in here. You can have the natural log. Yeah, there's natural log of 3. Here's the common log. Okay. Now, each one of these functions these are kind of common functions. If you use Excel, you probably have used these. Here's an interesting one. Here is here's a factorial. Okay. Factorial is taking 1 times 2 times 3. That's another function in here. Another thing that you can do here is use scientific notation. So here's 1.3 times e to the 4th. Okay, so that's 1.3 times e to the 4th. I could also have in here, let's just change this to not 44. Okay, so I can use scientific notation too. So there's a lot of functions like this, and you can put functions in functions and arithmetic in functions, okay? And so a couple of other things in here. There are lots of other functions, kind of ordinary things. Our old familiar pi, okay? And how about if I wanted to take pi and do something like I'm going to truncate pi. Let's see if that works. I have to get it right, though. So truncating is removing everything to the other side of the decimal place. So I can truncate pi. A couple of other commands here. How about if I round pi? And then I'm going to put pi in here. But I'm also going to say how many digits I want to round it to. So I'll say x equals 2. Okay, so I've rounded pi. Let's see. Factorial scientific. All right. What I'd suggest you do is go do some. Yeah, it didn't do it right there.
I don't know what you did.
Yeah.
Didn't round pi.
I didn't round pi. Yeah, I know. I didn't put the right parameter in here. Give it a shot. Try it out. Help each other. Hey, we're going to redefine pi now. It's a new world, Ken. I don't know what happened there. I'll find out. Okay. Give it a shot. Try it out. Help each other. Go through. Calculate some things. Put calculations in calculations. Get some experience putting things into R. And make some mistakes. See what the mistakes look like. If you don't make a mistake on your own, put one in. Okay? Fix it up. Yeah. Yeah. I used another command, the floor and ceiling command. So in other words, it's taking it up to the nearest integer or down the floor. This is actually an experience that's very similar to what if you had to program an Excel spreadsheet. It's exactly the same commands and things, except you're doing it line by line here. And has the same problems. If you forget to balance the parentheses in your expressions, you're going to run into an error. In Excel, it comes up with a nice window that says, there's something wrong here, this will just give you an error. Okay? Keep trying. All right, we're kind of moving on this. I think let's try the next step in this, which is actually creating some variables. So we've done our calculations. We told R to operate just like it's in Excel. So these are essentially the same kinds of, in Excel, if you were to try to do this in a cell, execute one of these, you just be putting this equal sign and whatever this is. So it's a very similar thing if you're familiar with doing this stuff in Excel. But now let's kind of get into the other part to this. I'm going to clear, I'll tell you what, I won't clear the screen because we may want to save this and you can look at it later. All right, now we have numbers we're working with here, but a lot of times, obviously, when you're doing research, you need to work with variables. So we're going to create a few variables. And we're going to, let me just create a variable here. Better stick with my script so I don't forget here. So I'm going to create a variable. I'm just going to call it DAV. Now look at what are good variable names. They can be long. They can have periods in them. But I don't recommend that you put special characters in, like, asterisks or anything like that. Don't try to put those in. And also, you can use a variable name that's a good mnemonic device for you. It's something that helps you remember what you have. So you can have the variable name that you like. This is one of the few times in study that you can do something that you like for yourself. Okay. Otherwise, R is going to push you around all the time. So I just put something that's just DAV, but I could add DAV.passmore. I could add David.passmore as a variable name. I could have, this is a variable that includes my name, all as one variable name. Lots of things I could do with it. So it's quite flexible. The only problem is you have to use it later, right? So let's do that. Now, I'm going to create a variable here that is called DAV. And notice it's not cap DAV. And if I had cap DAV in here, it would be different than DAV. Not the same. Entirely different. So I'm going to use another operator, which is a left caret and then a dash. Okay? And this is what's called an assignment operator. You might read it as contains, might be the verb that I would use here. And I'm going to finish this out by putting this in, 33. So I'm going to create a variable that contains 33. Okay, that's the way to read that. So it's just a less than sign with a hyphen. Okay? It's an assignment operator. So you're making that value on the right-hand side assigned to the variable with the name DAV. So let me go in and execute this. So I'll do a control return. And then, so it doesn't show me any error here, but it doesn't show me anything else. Now, if I just type in the variable name and execute that, there it comes back, right? So I have a variable name in here. Let's do a couple of these in addition. Now I'm going to modify, again, because I just don't want to type, I'm not that kind of guy. So let's put a couple of other things. Let's say I want to have Dave be equal to plus 33 plus 44. Now, I'm going to execute that in a second, but notice what's going to happen. Dave 33 being assigned to Dave will no longer exist. I'm overwriting Dave. If I wanted it to be something different, I could call it Dave 1. But right now I'm going to overwrite that. So let's execute both of these commands again and see what happens. Okay. So now if I just execute, tell me what's in Dave, just by typing the variable name in, comes back 77. So inside this part of the expression, the right-hand side of this expression, I could have any anything that I want. I could have a calculation, I could have whatever I want in there, and I can replace the variable name with that. In other words, assign those numbers to that variable name. Okay? Let's try something else here. We've used numbers so far. How about if we try something like, let's see if this works. Yeah, made a mistake. Okay. Okay, I did it right that time. Now, we've been using numbers so far. What we have in here is a variable that's called a string. In other words, it's not a number. It could be a number, but I could be treating it as actually like an alphanumeric character. Now, again, if you've used Excel and you've tried doing calculations on columns in Excel that look like numbers, but it turns out there was something else. Maybe they were formatted as a date, or maybe as text, and then you go to try to use them in a calculation, and Excel says, I don't know what that is, right? It says the text. That's exactly what's happening here. What I've done is rather than enter numbers, I've entered a string. I guess that's another way to, this is called, typically in R, this is called a string of characters. This is some sort of alphanumeric string inside quotation marks. And this is going to be handled differently. So if you were entering a variety of things like names or other things like that, they're going to have to be enclosed like this. And this is how we differentiate between numbers. Now, can I calculate, can I add Dave to Rose? No, right? She's younger. No, it doesn't even work that way. Okay, we can't. They're alphanumerics. They don't work. Okay, so you're going to do calculations typically. You do calculations on numerics. You do other manipulations with strings. So these are a couple things you may want to try. Now I have a couple of other. So you could put any expression on the other side of that assignment operator to replace into the variable name. And there are lots of different ways to format your variables. There are lots of different ways that you can create variables and create arrays. These are things that as you get into R, you may learn more about. And you'll have to learn more about if you're going to do some analysis in R. Okay, so there's a piece there. Now I'm going to copy. I have some file material here. Some code I already have together. Okay, now notice I had some code I worked on outside here. I don't need to worry about that. I can just paste it in here. And, okay, now, now we're going to use something that's called a combine function here to make actually an array of data. So the variable we assign to Dave, the value that we assign to Dave is a single value. But I'm going to create a vector. A vector is nothing more than a string of numbers or string of values. And I'm going to create this vector, and I'm going to put it into X, but I'm using this combine, a little c in front of this here. So I'm going to create a row with these 6 numbers in it, and I'm going to call that vector X. So let me execute this. Okay, if you notice in the console results, then what I've done is I have replaced, I've created a row in a variable called X, and that variable then has a variety of things that I can do to it. Okay. Okay, so that's a way to get that in. And you can actually execute a variety of commands on top of that, too. I'll show you those in a little bit. Another piece of code that I want to bring in here. Now, so I've created a simple vector that's just one line of data. And so you can put any number of things in that. It could be a very long line of data, right? I just have 6 elements in that vector right now. So let me go down here. I'm going to press this in. Now, I've already pre-coded this, so I'm going to create a new matrix, and I'm going to call this matrix B. And notice I've used a matrix command in here, and then I have a string, a vector. But then what this says is that we're going to have 3 rows and 2 columns. And it's going to place the first 3 items in the first row, the second 3 items in the second row. So I have here a 3 by 2 matrix, okay, 3 rows by 2 columns. I have 6 elements of data to fill the matrix, and I've used this matrix command to take the data that I've combined, the 6 elements I've combined, and put them into a matrix here. So, so let's just try this here. So, now execute this. Oh, I've got here, got some things left over from copying this. Say that again.
22 to 25 first.
Oh yeah, okay, right. Yeah. No, is that going to be in there? Yeah. Okay. I had too many thingamajigs in there from when I copied it. Yeah. So, yeah. Okay. I copied that from a place where the continuation lines were in there. I didn't just get them out. So, yeah, they're on the console here. You see, yeah, they show up here. So basically what I've done here is I've created the matrix. It's a 2 by 3, or excuse me, a 3 by 2 matrix. 3 rows by 2 columns. I have 6 data elements. Put the 6 data elements in. And then I've said print it out. Show me what it is. So I print it out, and it has index numbers. Okay, so I have the first and the second column and the first, second, and third row, and the matrix then shows up as it's supposed to. Okay, so I've entered a matrix in this case. Okay. So we use this combine argument then to put a whole bunch of elements into a vector. I've been able to use a matrix command in combination with the combine command then to create a matrix from those data. So you can see this, and you're going to try these things on your own in a few minutes here. But let's look at a couple of other things I want you to try with this. So with some of these things, go back up here to X, for instance. Which one there? Oh, yeah, right. Okay. All right, good. Okay, so let's do a couple things here. So we created a couple things. We created a vector called x, and we created this other matrix. But let's just work with x for a second. So one of the things we can do is do operations then over the vector. So let's take the sum of x. Okay, so that's the sum. That's very simple. In other words, you didn't have to write out a series of commands that said this plus this plus this plus this. You have a sum in there. And this is very similar, again, to what you have in Excel. And how about this one here? I'll get a couple of these functions. So in addition, I want to get the square root of every number in the array, and I also want to get the square of every in the array. So let's try the square root first. Okay, so that's the square root of every element in the array. Let's take the square of every element in the array. Okay. So it's possible for me to conduct operations on vectors and matrices, too. So you can do simple calculations, and also you can do calculations across a variety of data elements. Okay? So why don't we give that a shot? Now, you got a couple of things in here. You got the replacement, the assignment term, and you should fiddle around with that and put some expressions in that so that you get that down. Also, we have the combine argument, which allows us to combine things. We also have a matrix. So you might want to try doing this on your own, printing them out, making these things up. Let's try that out. And I'll show you some other things with data frames here very soon. Give it a shot. You can try what I have up here and then branch out on your own. One other thing here we might want to note is obviously if you took and modified a vector, you probably wouldn't want to, you probably want to save that someplace. So let's create another variable here. I'm going to call it y. And I'm going to assign the square root of x to y. And then I want to print y. We'll see what it looks like. Okay. So what I've done then is I've not only done an operation on a vector, but I've saved the result of the operation into a new variable. So now I have a bunch of variables in here. I have a matrix B in here, and I have a row vector x, and I have a row vector y. Row vector y is a transformation of what the data is in x by taking the square root of that. So lots of other functions you could be using to transform the vector, right? And there are other things you could be doing on that. So you might want to try some of those out. Look them up. Now, this is a chance for you. We got a little bit of time here. This is a chance for you to make sure you know how to use the help files and see what happens if you want to do something new. A little time to explore. Okay, now, a couple things I would like to do before we're going to take a brief break because I think Chad has to, there are mice in there running on the treadmill. They have to be out because of PETA rules. They have to put new mice in the camera. But we're going to take a brief break because we have to switch to another Google Hangout because we don't run into this time things. First of all, do you have questions about this? You can begin to see that, I mean, what we've done so far is really just use R for calculations, for preparing data and things like that. And it kind of, I think what you should summarize from this is it's not very different from other things you may have done in Excel if you've done Excel spreadsheets. Very similar. It has a syntax that you have to learn. You got to learn to mouse around the panels. You have to figure out how to analyze the errors that you make. We're doing really simple things now. But also recognize that R is really, in some ways, forgiving because you can try these things one at a time. If you've run an SPSS or a SAS file or a STATA file, one of these things, you make an error, you run it, and then the the whole thing runs and crashes, and then you come back and fix it. This case, you can kind of check your work as you go along. A lot of times when people are creating new variables, you know, they're transforming variables in some way, they're calculating new variables from other variables by summing them or doing some transformation of them, of those things. A lot of times they say, well, looks like it worked, but if you've ever done this programming like this, you get back and say, oh, well, you know, how did that, am I sure I had the formula right, you know? It's kind of like Rose is working with Mark back here and showing how you could take that B matrix and instead of making it a 3x2 matrix, you could make it a 30x20 matrix, and it would fill all those 6 numbers in throughout the whole matrix for you perfectly, and you'd have all this data. You wouldn't even know if you were trying to set that up. You wouldn't even put that in. You wouldn't know necessarily unless you checked your work. So one of the things I like about R is that you can get, if you want to check something, you can go into individual commands. You can make sure that the calculations are correct. And if you're like me, I like to do that. I don't have all that much, and I work with a math major, so that helps. But I sometimes have to do things on my own. So this helps. Okay? And there are a whole bunch of functions. We really skimmed the surface of what happens with some of these functions with R. If you type in question functions on your upper left-hand piece, you'll see that it'll come to a place where there are a list of functions, trigonometric functions, you know, statistical functions, just about any other function you can think of that's in there that have been adapted. So there are lots and lots of functions. We've just shown you some of these so-called primitive, miscellaneous primitive functions here. There are lots of things that you can do to make your work. And it's kind of like if you work in Excel, you know the same thing. A lot of people have done square roots, and they multiply things together, subtract, multiply, divide, and those kinds of things. But you want to do something exciting, you end up doing things like random numbers and all sorts of things. Well, then there are other functions for that. But they all get entered in roughly in the same way. And the rules that we've talked about this morning are the same all the way along. Command line, each command line executed, you make a mistake, it kind of tells you, and then you can move on from there. Okay, do you have questions? I walked around, Rose walked around. How are they doing, Ms. Math? Okay? Okay, good. It's good to have the, what's that? I know that, but don't. She's over there conspiring to revolution with doing something else with Simon here. Okay, but you know, you can pick up now. What you have to do is, I found with R, one of the ways to pick up a lot of this is you can actually go out. It's kind of like SPS or SAS. You can go out on the web and you can find data sets, lots of data sets. As a matter of fact, there is a package of data sets that came with your release of R. I mean, lots of things in there that you can practice with and look at. You can see other people's solutions to these things. You can try all these things out. None of it hurts. Okay, so lots of opportunity to do that. And remember, the other key feature is that it's free. I think that's the one we like. Okay, we're going to take a break here in just a few minutes, and I'm going to ask Chad to break it down. Now, in the next section, we're actually going to do some data analysis. We're going to read data in. We're going to put some data in what's called a data frame. And we'll also be reading data in from a CSV file, you know, comma-separated file. And I have 3 files for you. Two of them are called small. There's one that has about 100 cases in it. And it's actually a data file that we have tortured our own graduate students with when they take their comprehensive exams. We have other forms of torture. Just because you have this now, it doesn't mean we don't have other forms of torture in the background. So this is your data set, Veronica. Did you like it? It was fun. Okay, good. Okay. So we have a small data set that has some toy data in it. And then we also have a sample of about 1,000 cases with 57 variables from a data set that's available from the U.S. Mine Safety and Health Administration. And this contains accident and injury information about United States miners in underground and surface coal mines throughout the United States. It's a complete census of all reportable injuries. And we have data from 1990 until, I think, last year. In the one data set, I've taken 1,000 cases out of that just so that you can work with it. I also have made available the entire 187,000 cases that are in that. Now, what I'm going to recommend that you do right now is that you download those. Those are on the sheets I've given you, and you should be able to get to those URLs. Download those data, those CSV files. We will use them, but I don't think we'll crash the world here if you try to bring down the big data set. I think it's a couple of megabytes, and maybe 4, 5, 6, maybe 9, I don't know, megabytes something. Bring it down. But you'll see that R can handle that very well. Now, a lot of times questions come up, how much data can R handle? We're going to be showing, we have a pretty big data set, 57 variables. We'll have a couple 100,000 cases. That's not very much data in the world. If you go out on the web and look at, there's a Twitter analysis, right, with R, with I don't even know how much data are in that. There's billions probably of data elements in there. But one of the things about R, and it's going to get fixed up soon, I think, is one of the things about R is that all of the data is kept in memory on your computer. So a little different than the other commercial programs. So this is going to, so that whole 187,000 cases times 57 variables, you're going to see that there's string data in this and all sorts of stuff, is actually in memory on your computer. So this is limiting the kind of big data science stuff that people want to do, but there are advances in that move along. I imagine another year, if you have a dissertation that is going to have 10 million cases in it. We actually had a student who'd analyzed 1 day of angel data. Not Rose, we had the student, and he had over 10 million records in the data file. It was a bit of a problem too, even for the other systems. So we'll have a chance. I want you to download these now, and we'll go around and make sure that you get them downloaded properly. I would store these on, if they go into your downloads folder or something like that, put them on your desktop. Okay, we're back for the second part of this session, but I wanted to mention to the folks at home, we have one question that came in, was about the size of the CSV file that relates to accidents CSV, and somebody asked, could we take that down from 109 megabytes down to something smaller? Yes, but I won't be able to do it right now. I will I'll put that as a zip file out there. We'll compress it. And I'm going to do a follow-up to everybody who registered for this. That'll have video information as well as the CSV information. So yes, we will do that. Okay. I said this morning we have mainly syntax, mousing around, couple of functions, not really too much in there, but really important building blocks. If you're going to use R, you need to practice these things and get moving with that. So actually to use R beyond what we have, there are other steps obviously you need to go through. You have to have a little more sophistication, but the basics are there, and you'll be able to find some of these things. Now, the next thing we need to do is actually have data. For most cases, we're not going to have data that you type in. You might have 1,000 cases, 60 cases, or whatever. You don't want to spend time doing that. So you're not going to be entering data in as vectors and the like that we have. So that's one way to do it. But there are a couple of other ways. We're going to talk about 2 ways to bring data into R. And they're fairly common. But one will rely on the commands and that we've had before, but also the other one is going to read data from another file. Now, there are lots of ways that you can get data beyond what I'm describing today. We're going to be reading in a comma-separated file, like an Excel file, just not kind of XLS file, but a comma-separated file. It'll have a header in it. In other words, it's going to have titles of the variables on the top in the first row at the top of each column. But that's not the only way you can get data into R. There are lots of different ways, and a lot of those are shown. If you look at some of the tutorials, you can see that. But I want to mention that If you're currently a SAS user or an SPSS user, there is a package that you can get that will allow you to bring in system files that have been created in SAS and SPSS into R. So for instance, let's say you've been using, I don't know, and Rose has a class where people use SPSS and using the general social survey, and so she has a .save file in that. If you have those kinds of files, you can actually import them in a snap into R. There's a kind of a one-command setup to do that. And so if you're already using SPSS and you want, or SAS, and you want to use the same data in R, you can do that, and it's fairly easy. There's a package, and the packages are sets of programs that do various things. They're packages for doing, you know, thousands of packages to do all sorts of things in R. Financial analysis, all kinds of things. Highly specialized, but you don't want them on your computer all the time. One place you can see these packages, and the ones we have installed, is in the lower right frame. And you can see we have a couple of things installed. We have a graphics package, we have graphics devices, methods and classes, data sets. There are a whole bunch of other packages that are here that could be installed that we've actually downloaded to your computer. They just haven't been installed in this version of R. So for instance, survival analysis, some of you may do it. Survival analysis is when you have time duration data, and sometimes it's left and right truncated, and so that's a bit of a problem. So survival analysis in here. There are lots of things. So we have the RStats package and other things. But you can go out, and there's a couple of very simple commands which will allow you to bring packages in to directly off of the R site. You don't have to go through a lot of programming. You just bring them in, and you'll get additional packages. So if you have something that's specialized, like Chad does a lot of social network analysis, he downloaded the package for social network analysis. There's more than one, right? So for those of you who are at a distance, and Chad's a distance from the microphone here, Chad does a lot of social network analysis. There's an SNA package. There's also there's a package that was actually built at Penn State to do social network analysis. And this, in combined with various graphics packages and things, will allow you to do everything in social network analysis that people spend a lot of money buying software for and learning to run. And you do it directly in the context of R. There are lots of packages, like, give you an example, in social network analysis, there's something like NodeXL. And there are a couple of packages they're commercial packages that are out there. Some of them are rather expensive too, especially if you're doing network analysis, you know, not just people network analysis, but other kinds of network analysis, where maybe you're trying to figure out who's related to whom in maybe in Facebook, or you know, various transactions that occur. So you may be trying to design a sewer system. I have no idea what it is, but there may be a huge network analysis, or maybe the airline network is another one. So there are lots of packages that cost a lot of money to do this. Now R has a lot of this together. It has the graphics to support it, and also the analytics that are behind that. And that's just one example, probably out of thousands of specialized areas that are necessary. There's a lot of data out there. You're going to find out that the package that you have in front of you here, we have the so-called data sets package. If you were to click on that, you'll see that there are lots of different data sets that you can use right on your desktop right now to practice using R. So there's a lot of good stuff in here. So there are lots of ways to get data in. The ways I'm going to show you today, one is kind of primitive, and the other one is very commonly used. So the one we're going to do is we're going to create a data frame, just so you understand this idea, and then we're going to read data in from several files, CSV files, one of which is large, and if you're on campus here, you shouldn't have too much trouble downloading that. You may have done it already. And we're going to do some analysis, and the analysis will occur of numeric data as well as string data. So we'll see some of the differences here. And we're going to do some very simple analysis. We're going to use statistical functions to get the mean, the median. We're going to get the range, standard deviation, variance, things like that. And then we're going to plot data. Plotting is another area. There are a couple of packages. There's one that's called ggplot, which we don't have installed on this, but you can very easily get it, download it, and it has very, very high quality graphics packages. I mean, these are, you know, publication quality graphics that you can get through R, and highly configurable color graphics that you spend a lot of time pulling together. And if you've used, I have nothing against, we've used Excel. It's kind of like the Dan Quayle thing. I've known Excel and you know, very well in my lifetime, and I respect Excel too, and I like Excel. But if you're dealing with that, you know that how difficult it is to get really high quality graphics out of that publication quality stuff that doesn't look like it came out of Excel. So there's a lot of options in here for this, and you can get these other packages. They're very, very configurable, very extensible package here, and you can tailor it to your needs. And with all of these packages, you're going to find a user group out there that's interested in this, and they're pushing ahead with all of these things. So typically, in something that you're doing, you're not going to be out there on your own with these packages. There are lots of people who will have examples, and there's a lot written about this. So, okay, so let's do a couple of things here, and then you can try these out. Why don't you watch right now, and then you can try in a second. Okay. A data frame is nothing more than kind of another way to express a matrix in R. So what I have here are three vectors, 3-row vectors. One of them is called N, which has 3 data elements in it, 2, 3, and 5. Another one that's called S, and I'm combining 3 string values in this with AA, BB, and CC. And there, notice that because they're strings, they're in quotes. The third vector has logical operators in it. There are lots of operators that you can use in terms of logic, and these happen to be, well, these are established terms in logic in R. So these are also valid values that can go in a cell. So I have 3 rows of data. Notice that I have 3, if I were to think about this as a matrix, I have 3 columns of data too. So I'm going to define each of these, N, S, and B, and then I'm going to create something. I'm going to use the data frame argument here to put together N, S, and B into a data frame. And I'm going to replace that. I'm going to call that data frame DTF. Now, I put something in here I want you to notice. Notice I have an equal sign in here. Formal R analysis requires you to use the left caret with the hyphen. It's possible to use an equals. R will recognize that, but in some packages, not always. So I just want to say this is going to work, and it looks a little different. It is replacing, in other words, that vector 2, 3, and 5 is going to be replaced in N as a vector, okay, because it says equals. And so that's if you're doing ordinary mathematics, you might think of the equal sign as is equal to, is solves as. In this case, it's kind of like substitutes for, becomes, combines, is assigned to. So we're going to assign these 3 things. So let me do that first. You don't want to do that. So I'm going to create these 3 vectors. Okay. So I've done that, and you notice what happens over here is that not only do I have in the console, I have an echo of all of the commands I put in, but also notice in the upper right quadrant, the upper right pane, is that it's keeping track of the variables that I have. So there are 3 variables up there, and 3 vectors up there, and it's defining. So it's also telling me the type of vector that is. So you notice that on the upper right over here, when it's saying B, it's calling it a logical vector. It's a 1 row by 3 column vector, if you want to think of it that way. That's why that's there. And it has logical operators in it, true, false, and true. So R has recognized those as actually the type of value that is a logical value. The second one is a numeric vector. You notice how that's being documented. We have 2, 3, 5, and it has 1 row and 3 columns. So this is your way of kind of documenting the nature of the data that you have in your environment. And we have another vector called S, and you notice when I mouse over even on this, it shows it's a character vector. And we have 1 row and 3 columns, and the characters are enclosed in quotation marks. And so these are these alphanumeric. So we have logical, numeric, and character vectors. So I executed these 3, and let's just take a look just so we see N. Oops. So I'll just print these out. Okay. So all I've done there is I used the command, the single, put the variable name in there, or the vector name in there, and it prints out the vectors one more time. So now, but all they are now are 3 disconnected row vectors. There are 3 vectors in here that are row vectors, just all together. So what we're going to do is create the matrix here. So we're going to use this statement right here. And I'm going to create a new data frame. That data frame is going to be called DTF. And then I'm going to use the argument here, data frame, in front of these 3 things. So it's going to take N, S, and B and kind of merge them together, concatenate them into a matrix. So let's try that, see how it works. Okay. No problem. So I get the words right here. DTF should print the data frame. Yeah, right. Right. Good. Okay. So notice what I have up here. The mistake I made is I didn't have a comment character in there. I pulled this off of some notes I had. So I've created DTF, which is a data frame, and it said, okay, I want to take this N, S, and B and turn it into parts of a matrix, so 3 elements in the matrix. So when I printed this, so I printed DTF, and I just put this little comment in, said here. So it came down here, and it says, okay, DTF prints now. You can see that it has a column. The column names are on here, N, S, and B, right? And then the elements of N are the rows. Okay, so what it's done is taken N, made that a column, S made it a column, and B made it a column. So when I read across, if this were a person or data related to somebody's record, there would be an N, AA, and true, whatever those mean. So that row in that case now represents a record for analysis. Okay, so another way to think about this, thinking in Excel terms or SPSS terms or in SAS terms, the columns show the variables and the rows show the cases. Okay? This is a data frame. Now it's possible to do that. You could, read a data frame in and create a matrix in that way. And I'm going to leave that up there, and I'll show you a little bit in a bit. You can try some of this out. You should give this a shot. As a matter of fact, before we move in, why don't you just try this right now? Take a few minutes and try this out. Put some different values in there. Just get it. Just give this a try, because what I'm going to move to next is going to, bend the memory of your computer and your own memory from this a little bit. So, okay, just give it a shot. Now, I've added something in here. Not only have we printed the DTF data frame, but notice the other commands. These get to be important in the next step that we're going to be going into. I'll highlight one of these commands here. I've printed, I'd say DTF $S. What that's going to do, it's going to print only S. Let's look at that down here. Right here is the answer. So it's printing out only S. So notice the notation up here, in order to get an element of that data frame, I use the $sign. Let me put another one in here. How about if we put N in here? And sure enough, down here, it prints only N. So that's one way to do this. Now, how about if I want to print only one row in this data frame, this matrix? Another way to do that is right here. Now, look at the syntax on this. It has DTF, open bracket 1, comma, and then has a space, close bracket. Now, let's deconstruct that for a second. What that's saying is that I want to find DTF, and remember when we talk about matrices, we talk about them in rows and columns. So what we're going to do is print a row of this, and let's just highlight this. Okay. So there's row 1 of the data frame. So I have row 1, N, S, and B, and what that's showing is that row 1 is 2. If I were to change this, let's say row 3. So that prints row 3. So it's possible then, I'm going to say to address particular parts of the data frame. Now, my guess is that very few of you will be entering data in data frames. Most of the people are going to be doing some statistical analysis, probably have a lot of data, and you're not going to be entering things that way. Probably. Possible. But not likely. But I think one of the takeaways from this is how you address a particular column in that data frame. So the data frame then can be addressed by particular columns by noting the column name right after a $sign that includes this. Let's do S of this here. So I'm going to print S in here, which is a column of this matrix. I'm going to print the data frame one more time here. And so what you can see is that we've selected particular rows, particular columns to address. Now this is okay. We can see this in a in a small matrix like this. But what if we were analyzing, as we'll be doing, or what if we have this 57 variable by 187,000 data set that we're going to be looking at in just a few minutes? How would you find something in that? Let's say, well, typically people are doing things like finding because they want to they may want to find a particular case, or they may want to make statements, and we're not going to talk about these statements, but you may want to have statements that will recode or restrict data. So maybe you only want we're going to look at this mine injury data. Maybe you only want to find the people who died as a result of their injuries. So they'd be using particular variables in if-then statements to do that. Now we're not going to talk about recoding or looping today. Looping would have us go through and do things to either along a vector or along a set of cases, and recoding would have us take variables and turn them into other variables. Okay, so we're not going to get into that. That's something you obviously do when you do statistical analysis. You usually you reshape the data that you have with you. And one of the things in R and any statistical analysis system is preparing the data for analysis. So most of the time you're not just going in and pressing a button to do the regression. You usually have to do something to condition the data properly so that it'll work in the regression equation. So you have to have a way of reshaping the data. So everybody does recoding and looping and all that, and that's something you need to know how to do in here. You have a system like this. Part of it is data preparation. It is something you always have to do when you have data. And also, when you do data analysis, in other words, you're trying to reduce the information. We're going to try to reduce some of the information that we have in this 57 by 187,000 matrix down to some form that we can actually work with. So that's part of data analysis. Sometimes reducing that is finding out how many there are, or what their average is, or what their range is. Those are the kinds of reductions that you make in statistical analysis. Or is one vector related to another vector, another variable related to another variable, those kinds of things. And also we have data visualization. So all this together, gets to be important. So it's really important. We're going to do just a few things here, but there really is more that you need to know to be a working data analyst with R. Okay, everybody kind of get the idea on this? Okay. One way to get data in, many ways to get data into R. We're only dealing with two today. One is a data frame, and the next one is to read from a CSV file. So I have prepared a couple of CSV files. You can find CSV files everywhere, right? They're all over the place. You can get all kinds of sample data used in your summer class general social survey data, right? Big Excel data set, right? That you can convert and use. So there's lots of this stuff around. As a matter of fact, I think there's a package that a data set someplace in here that uses general social service survey data from about 3 years. I think it's even loaded on the data sets in your machine. So there's a lot of data around. So what we're going to do today, I'm going to just pick a couple of data sets. 2 of them are small. One is large. And when I say large, I don't know what I mean by that, because it's not too large that I can't get it into the computer here. It just happens to be a big data set. When I say large, it's not the kind of thing that you can sit down and look at. A lot of times people feel really comfortable. They say, well, before I do the data analysis, I think I'll roll through my data, see what it looks like here. 187,000 cases you don't roll through. You had some data that you were analyzing over here. It fit way off the screen, right? Yeah. R won't even let her see it. That's just it. We're not going to let you look at that. I mean, you have to be able to do this. It's kind of like flying a plane, and when you have to land in the bad weather, you can't see things. So you have to trust the instruments and things that you have. So that's what you have to do here. So we're going to do this. Okay. Here's what I've done. I have this so-called small data set. You should have downloaded this, and this is the one that had the URL problem on the sheet. So what this has done is it's used a command that's called read CSV. Now what I've done here is I'm creating a new data frame that's called small d in this case, and I have my assignment operator, and then I have read CSV, and then some quotation marks, and you have to define this from the root of your machine out. For most of you, it's going to be exactly what I have here with if you're on a Macintosh, with your username and then out to your desktop.
So you have it. I'll stand close to David so that people around the park can pick up my voice too. So if you've saved a CSV file out on your desktop, go out to your desktop and right-click on it. And then for people on a Macintosh, it's going to be Get Info, and for people on a PC, it's going to be Properties. And inside the Properties piece on the PC, you go to the Details tab, and it will give you the path name. And so you'll need to copy that path name in order to be able to put it inside. For people on a PC, the users is probably a capital U, and for people on the Macintosh, it's probably still lowercase.
Okay, let me do that on this here phone. Okay. That's a good example. This is on the Macintosh. This is my path. It's from users. This is right from the root of the machine. Users, out to my username, out to desktop, and then the data set name, which is why when we come out here, this is the entire path. So it starts out with a slash and Macintosh users slash username, out on the desktop, then small data.csv. Let me just go around and see if we have it here. Okay, now, some of you are still uploading that, but for those of you who have, can also a couple things you can do here. One is you could say, okay, well, I wonder what's in small d here. So you could type that in. And then run it. Well, okay, there they are, all 100 of them. Okay. Now, if I had, when we open up the 187,000, I'm going to tell you right now, R will not show you those. It's not going to show you all that stuff. It's going to truncate it. So if I was the kind of person who really wanted to see what the kind of data were that I had in here, I could just type it in and, you know, just print it out, which I've done. But another way to do this, I'd say, okay, well, let's look at this data set that I have here. This data set that I have has variables in it. One is called gender, another is income 2012. Here's marital status. Here's high school graduation status. And here's our SAT writing score. So I know that there are 5 variables in this. So let's say I just wanted to find out what the variables were. Another way to do this would be to type in another command. Names small d. What names small d does is give us the names that are in the first column. This CSV file had in the first row at the top of each column a variable name. R recognized that as a string that probably I meant to have be the variable name. So one way to do this is to verify would be to just type in small d and then hit back, but then you get all of the data back. When we have 187,000 cases and 57 variables, or a case where you have 360 variables and 500,000 data points, you're not going to print them out and look at them. So you might ask the question, what are the variables that I read in? Well, the way to do that is to use this names small d command. And this will give you the data set names. Now notice that up here, everything is being kept track of here for us. So we have some values, variables that we've actually created ourselves. But we also have some data sets or data frames we created. Here, the data frame here has 3 observations on 3 variables, right? And there is what they are. So again, we have documentation that shows what's in this. And I'm going to, now by the way, I can move these frames or the panes around a little bit. So let me close this up, and then we have small d. Okay, there is an example of the data that are kept in small d. So we have in this upper right-hand frame, we have each of the variable names showing up. It tells us the type of variable it is. So they're all integers. Okay? And in addition, it gives us a sample of 4, 5, or 6 data points after that, so we can see what they look like. So that upper right-hand frame is helping us document the data matrices that we have. And it'll tell us a little bit more about things. You can also run various commands that will show you the structure of the data that you put in. Okay? Now, I'm going to fiddle around with this data set a little bit because it's small. But you have a couple of other data sets that you've uploaded, you should have uploaded. And we're going to do a few things with this, but then I'm going to turn you loose and have you try a few things on this. So let's use a couple of functions in here. One of the things I might want to know in this data set is what's the mean income in 2012 in this group. So the way to do that, and again, we're going to use the convention that we used before. We're going to call this so we're going to get the mean of this. This is the average, right? And the first thing we're going to do is we're going to read that from small d, and then we're going to select a particular variable in that, and we're going to use the $ to do that. So we're going to take a particular column, and it's income 2012. So the thing that we want to return in this case is going to be the mean of that vector, that column vector, and that should give us the mean income in 2012 for this group. So let's see how this works. And I've selected the income because I've pointed to small d as the data frame I want to work on. Then I've used the $ to indicate which of the columns I want to work with. Let's see how this works out. So there we go. So from this, I've calculated the mean income in this case, which is $26,000 or so. And I can do a couple of other things in this case. So let's do something tricky here. I'm going to say, what's the mean of small d? Notice also that I've obeyed the case on this. Small is lowercase, gender in this case happens to be uppercase, so I had to maintain that. Otherwise, it wouldn't know what I had. So I'm going to take the mean of gender. By the way, what is that going to mean? What the gender in this case is coded 0, 1. What is that mean of gender going to tell us? It's going to show us the percentage in the vector that are coded 1. Now, I can't tell you whether they're male or female because I did this with the simulation program, because all it is numbers to me. I called it gender. Okay, so if we take the mean of that vector, we're going to find out the proportion of people in that vector who have a 1. So let's take a look at that. So it's 0.454. So 54% of the people in that column have a 1 in there. If that was male, that means the 54% were male. Okay? Let's go through a couple of other statistical indices. Most of us understand the concept of the average. Center of gravity, one way to think about it, is kind of where the balance point for the whole data set. Let's try the median. And I think what I'm going to do here is get income in this case. So there's the median income. Median income in this case is $26,209. The mean was $26,133. The mean and the median, they're pretty close. The median is the point at which 50% of the people in the sample are below that point. Okay? So in this case, the mean and the median are pretty close, and we had a couple other things. You probably think that this is kind of normally distributed. Okay, so we have the mean, the median. How about a couple of other things in here? Well, let's take the standard deviation. And that is, I'm going to get the standard deviation of income. If I can click and copy. Okay. I'm going to calculate the standard deviation of income in 2012 in this data set. And there it is. It's 1900. Standard deviation is the average difference, the distance of a particular case away from the mean, standardized by the variance, by the amount of variation that there is. So this is if we were to think about this, if this were a normally distributed data set, we'd have about 68% of the cases would be somewhere between 26,000 and plus or minus 1900 in this case. So, all right. And also, let's take a look at another term here, the variance. So I get the variance of income in 2012. Okay. Now, let's do something else here. So there's the variance. Let's create a new variable. Let's just call it, I'm just going to call it new. And I'm going to assign it to, let's see if this works. Might have to do this in 2 steps. We'll see here in a second. Okay, what I've done here is I've done a little calculation. I did this in the console. But the variance is the standard deviation squared. So when we calculated the variance, it came up to this number here. What I did is I created a new variable, and I used a whole bunch of things in there. I used the square root of a variance that I calculated, and it should come out to 1900, and sure enough, it does. Those numbers work out. So So you can see just by this example that you can not only calculate these things, but you can store them too as other variables. So maybe in the subsequent analysis, you're going to use the means for something else. You can put them into a vector when you create them. And you can do all sorts of calculations. So you can have complex calculations based on statistical and other functions that will produce new variables for you. Okay? Now we'll give you one other piece here that is the big daddy of it all. And this is I'm going to put it up here. So this is a command that's called summary. And here's what summary does. Summary gives us detail on every variable in the file. Notice here that it gives us the minimum value, which in gender's case is 0. It gives us the mean value, which is 1, and the maximum, which is mean value, which is 0.54, and the maximum value, which is 1. In income, then, it shows us the minimum and the maximum values of income in the file. It shows us the mean and the median. It also shows us the value at the first quartile. This is the 25th percentile of this distribution, and also the 75th percentile of this distribution. So when we use the word summary, then you can get a whole bunch of information about this. And you could actually take this summary and make it into a variable, put it into a matrix if you wanted to do that too. We won't do it in this case. So I want you to go in and use the data set that you have here and try a few of these things out. And then we're going to come back. I'm going to load the other data set on mine injuries, and I'm going to do some plotting, and then we're going to let you do a little bit of both, okay? And then you can explore both data sets. I would also recommend, if you have the oomph behind it, put in the whole 187,000 cases from mine accidents. Not a big deal. It's called accidents.csv. It's big, but not that big. Yes? Okay. There are similar terms in here. I think you can use skew also. Yeah. But you look it up. Yeah. Okay, so give this a shot, and then we're going to bring the other data set in, and then we're going to try all this together. Try a few things out. Now, I've done some reading of a data set. I've showed you what the data set looks like. I've gotten the names of the variables in the data set. Then I went through some very simple statistics to show you what the characteristics, these are descriptive statistics about these data. Okay, one of the questions is, can you get an abbreviated name for a data set? Yeah, you can. You'll have to convert that to, if you wanted to get it as a Google shortened term, you can do that. We won't be able to do it right now. You can give your file any name you want. Okay, I want to take a minute just to take a brief break from what you're doing to show you something else here, and then you can incorporate this into the rest of your analysis. I have read in both the mine accidents and the accidents file, and I'll use that particular file. I'm going to use the accidents file, which is the big one. Now, again, I could look at that, I could print all that out and see what variables are in that, but that's not very practical. So I want to find out what the variables are. I'm going to type in names, accident. Now, this is going to give me a list of the variable names that are in this file. There they are. Now, there's a whole bunch of them, right? Now, in this particular file, I gave you you can fiddle around with this file later on. There's some documentation for this. But in some of these cases, we have string data in. In other cases, we have data in that's actually numeric. So we need to be able to work with that. So let's just do a little bit of analysis here. If I were to put in the term summary, ACC, which is the data set that I'm working with, and then I'm going to type in How about accident type? And this is the so-called coded data. So I found accident type. It's one of the variables that's in this big long list. And if I run that, okay. So there I have for accident type. I know what this is. Now this happens to be. Let me see if I can get another one here. Accident type. Let's have a. Okay. Now that's not very helpful. It doesn't tell me all that much. So I'm going to create another kind of a thing here. I'm going to call this new variable. I'm going to call it frequency. Just freak. And in this, I'm going to make what's called a table. And I'm going to make that of this particular variable. Okay, now execute that. So I have a new table, and it's actually taking that variable and making it into a table, put it in freak. Now if I type out FREQ to show me what's in that, okay, now there is a frequency distribution of the values on that variable, but it's not very readable. So I'm going to use another command here, which is very useful in kind of getting good things. So it's cbind FREQ. And if I execute that, it actually gives me a frequency distribution that looks more like what you might expect. So there are 10,488 ones, etc. So what I've done here is I have taken the big data set and I've shown all the names, and you can explore these as you want. And then I ran a summary, and then I put all of the data from that particular variable into something called a table and renamed it freak. And then that gave me the frequency distribution of these data. Okay. So you might want to try that too in one of the other data sets you have. No, all that does is straighten this. It straightens this frequency distribution here out so that it now becomes a column. See, what this does is it just has all of these. So there's the 1, there's its value, 2 its value, 12 its value. It's just not readable. So cbind, all that does is kind of straighten that whole thing out and then let you prepare a frequency distribution here. All right, 2 more things I want you to do. Take a look up here at the top. We're going to do a couple of plots. Now there's an extensive plotting package in R, and the plotting package is really good. It's called ggplot, and you can bring that in as a package, and it has very good plots. I'm only going to do 2 plots here, and you can try plotting some other data, and you can see how well it works out. But I have a plot in the accident and injury data that is going to do a histogram, HIST, on that particular variable. So that variable is called the degree of injury. This is a variable that runs something from like 1 to 10. Some of it's like no hospital, no medical emergency, Band-Aid case, all the way up to death. And I won't put the value labels in here or anything like this, but let me do the history piece. Okay, there's a histogram that was created of the degree injury variable. Now, that histogram has a title, and it has axis titles. You can modify, go into the plot command, and look, you can modify the axis titles. You can modify the title of the plot so that it's more readable. And in addition, you can put color in this plot. And there are just a couple of little commands to do that. But you tailor it the way you want. Now let me show you one other thing that's important here, is that when you create a plot, you can export it. So you can copy the plot to your clipboard, or you can save the plot as a PDF, or you can save it as an image. Let's just try the image piece here. And so you can choose the type of file that you want, and where you want it saved, how big it's going to be, and if you want to maintain its aspect ratio if you change any of the dimensions. So you can do all of that when you export this, and you can figure out how to whether you want to see it after you export it. So, once you create a plot that looks good enough and has the right color and the right dimensions and everything, you can save it and export it. Okay, this is a histogram. You can make all kinds of histograms, and I'm just going to do a bivariate plot with one of these data. And this might make more sense if you were to try to plot the SAT scores versus the income or something like that in the other file. Be a little bit smaller, but now this is a really big file. I've loaded this in. This has 184,392 observations on 57 variables. So I'm going to run this plot. Whoops. So it's going to choke a little bit. And it should do something here quick. There it is. Okay. So here we have a bivariate plot. Now it turns out that injury is a categorical data point, and the total work experience is a continuous data point, but you get the idea. And again, on this, you can put the axis titles in, you can change the color, you can actually go in and change the exact color on the points in the plot. Now, some of you may have plotted swarms of points that are really important to look at, or maybe not that large, but sometimes there's one plot on top of the other. In the ggplot series, there's a function in here that's called jitter. And jitter is exactly as it sounds. If two points are on top of one another, you can set the criterion. Like if it's 10 points that are on top of one another, you can separate them a little bit so that they can be seen, especially if they're a different color. So that's a very useful little item. So now you can look in the plots package, look up plots in here. This is a bivariate plot. We've done a histogram, but there have to be a million different kinds of plots, and you can enhance each one of these, and you can export them as a PDF to your clipboard. The clipboard could go directly into a Word file, and the other files then you can manipulate, let's say, through other programs. So it's a lot that you can do, and you can change the background, all sorts of things on this. And there's very extensive, as I said, good plotting resources on our. ggplot tends to be the one that a lot of people favor and like a lot. So that's a package you could bring in. Okay. So why don't you give the plots a little bit of a try, and then we want to wind up here with maybe some. Okay, there were a couple steps in here that you need to pay attention to when we put this in. Remember, I used this little table statement. You can't, if you try to analyze the frequencies and the means and all that without first putting this into a table statement, you'll have trouble with it. And you'll notice when you start using the data in here, a lot of it, some of it's numeric, but it has NA in it. NA indicates missing value. We haven't declared a missing value on this. The smaller data sets will work out. But this thing actually has to have a little tuning before we would use it completely. But also you're going to find out that when you try to, some of the modes are mixed. Now, the simple small data set that has gender and income and all that, those are just numeric data. They're pretty easy to deal with. This has a mix of string and other kinds of data, which make this data set a little more complex. So, use basic R functions. We've done that today. We have read data in from a couple of sources. There are lots of different functions and lots of different ways to read data in. We've only covered a little bit of that. We've done some of the functions. There are literally thousands of functions. We haven't done everything. Then, so after we read the data in, we did some very simple analysis. We did some very simple descriptive statistics to look at the mean, the median, standard deviation, the variance, the range. We actually use a summary command to give all of that to us. And then what I've done here is I've shown you how to create a frequency distribution from data and how to straighten that out so you can see it. And there's obviously a long way between doing this kind of analysis and putting things into a table. But to give you an idea of what's over the horizon is that there are a lot of people who do data analysis in R and do all of their manuscript preparation, everything inside R and some of its extensions. They create manuscripts fully formatted from this. So it is possible. There's some extensions. One's called, not an extension, but some other products. One is called Shiny. And a lot of these move into, they create documents that are in LaTeX. LaTeX is what the scientific world uses to create documents. It's a markup language, and it's used quite extensively in most of the world, engineering and science. And in social sciences, everybody is still sticking around with Microsoft Word. So, but LaTeX is very extensible. I had a student do a LaTeX, her dissertation completely in LaTeX, and she took the file and moved it to a publisher, and they created a book directly from that. It was marked up just so perfectly, so it's possible. So anyhow, there's a lot of that. There's stuff built in here, so you don't just get these kind of clunky distributions and things out like we've done here. When you learn more, you can import more into the work that you're doing, and this actually, in the long run, saves time if you work this into your workflow. The other thing we've done is we've done some of these simple distributions. We've also done a few plots and showed you how to export them. You can try a few more of these. You might want to try ggplot and see what else you can do with that. Every one of these, if you look up the help file on them, once you get the package in, look up the help file, tells you how to do it and shows you an example. So it should be there. Just a matter of work on this. Okay, so we're going to wind down the Hangout right now. And for those of you who are, I don't know, maybe you're eating breakfast someplace or going out to have coffee, I don't know what you're doing at 2 o'clock in the morning here. But if you want to be in on an hour seminar at 2 o'clock in the morning, you're our kind of people. So, okay. So thank you very much, and we'll stay around here. We're going to stay around in the room in case you have other questions and things. So thanks. Good.